Good evening, everyone. We will start the class in 5-10 minutes. Let other people join. will start the class now. Good evening everyone. I'm Shefali Agarwal and this is our 10th TA session on the topic of advanced concrete technology. So in this week, if we go by course content, we will be studying about the second last topic on creep and shrinkage. Just 1 minute. So if we talk about creep and shrinkage, what exactly this means? Creep means loss of water due to restrained loads, and they are mainly time dependent properties of concrete, where shrinkage is loss of water when normally because of temperature change or any other reason, and creep is mainly when there is stress generated and there is a movement of water, or water is forced out of the concrete system due to pressure or stress. So this is a normal strain versus loading time curve of various shrinkage and creep. So if you see here, this is your free shrinkage. So with time your shrinkage is increasing, and after unloading or when it is saturated at that condition, what is happening? It is swelling. Same way we will talk about creep. So when you are loading, there is a sudden decrease in water and then it will be almost linear, and when you are unloading, again it is decreasing. So combining both basic creep and free shrinkage, you will get the observed total strain value in your system, and after you are unloading it, you will see a elastic recovery in the system. Okay. So mainly if you talk about like recovery area only, so these strains can be fully recovered when you are unloading your system. Okay, or you are resaturating your system. So here if you see, there are two things. First, you are unloading it, that is in the case of creep, and then second, you are resaturating it or adding more water to it. In that case also your strain value is recoverable, and it is can be called as elastic recovery. Okay, so what are the different effects of creep and shrinkage? When your axial strain increases with time, especially for example in columns under compressive loads and bridge pairs, in that case what will happen? Your deflection will also increases, mainly for example in case of beams and girders. Then next effect is stress relaxation. That will happen in case of pre-stressing concrete. When you have pre-stressed rebar in concrete, in that case with time, due to shrinkage and creep, your stress level will decrease. That is called as stress relaxation. And next is, there are chances of cracks on the elements due to loss of water, especially it is seen in the case of pavements and slabs. So first thing, if we talk about creep, so what exactly is the definition of creep? It is permanent deformation due to sustained load. So if you talk about any element, if we say this element is being loaded from top and bottom, what is happening? There is a deformation happening in this column. So this is a final shape, and this deformation can be due to various reasons. First is because of normal elastic strain. It can be due to creep strain. Creep is again movement of water outside due to loading or stress condition. Then third is drying shrinkage. So drying shrinkage also we will come up to it, what exactly drying shrinkage is. And fourth is due to thermal strain. So these are the four reasons of the deformation in your shape, and one of them is your creep. Okay, so this is an example which sir might have shown you. So it is one of the major example of creep. So this was a circular arc which have changed its shape to like this. So that is mainly due to creep or due to continuous loading over the bridge. So because of movement of vehicles and all, this arc have changed its shape and look like this. So what are the reasons why does creep occur? So first thing, when we talked about sustained loading, because of loading, what is happening? There are two two type of creep: basic creep and drying creep. So basic creep, if we talk about what is happening, the various components of your cement paste will have different type of will take up different type of stresses. So here it is, definition is given. So when load is applied, different components of the hardened cement paste take different extent of stresses. So how it will start? It will start from the within the CSH. So we know the structure of CSH. It will have pore water. So under high pressure or high stress, your CSH tend to diffuse to region of low stresses. This will result in the contraction of the small pores and will lead to the deformation of your specimen or your structure. Firstly, because of this. Secondly, what is happening? Once your CSH or your micropores are filled with your material, what will happen? Your water which are there in the other pores, in let's say micropores, it will start coming out and will lead to settlement of the building. So two things are there: firstly rearrangement, secondly expulsion of water. So first thing about basic creep. So this is an example showing what are the different factors which are affecting this creep. Firstly, we just talked about the CSH thing. Other thing is how aggregates are affecting your creep problems. So mostly only the paste. In if we talk about any concrete specimen, we have aggregates, then we have paste. So paste will have water, sand and cement paste. So mainly your cement paste will show the creep issue, and there is a equation and all. So if we talk about aggregate thing, what are the main things about aggregate which affect your creep issue is the how your aggregates are graded. So we have been talking about this thing since last 3-4 lectures, like your aggregate should be well graded in your concrete. If it is not well graded, what will happen? You will have spacing between your aggregates, and whenever there is a loading, firstly those spaces will be filled. So in that case, if it is not properly graded, so your creep problem will be more there. Other thing is shape, size, all those we should not use flaky aggregates and all these things. And lastly, the porosity. So if your aggregates are more porous, what will happen? It will store more water. So your porosity will also affect your creep issues. So here it's showing content of aggregates and unhydrated cement. If your this is decreasing, your shrinkage ratio is decreasing. So this is a normal range, 60 to 80% of aggregates and unhydrated cement. In this range, your shrinkage ratio is very low. However, if your aggregates are very less and you have more cement paste, in that case your shrinkage will be much higher. Same way, creep is showing the similar kind of behavior as this shrinkage thing. Other thing is like this is same thing, what how different type of aggregates. So here we are talking about different type of aggregates and their behavior. So with time, how shrinkage is increasing in different type of aggregates. So if we talk about this circular verse, sandstone have a higher drying shrinkage properties as compared to your quartz. So quartz show very less drying shrinkage as compared to sandstone. Same way, other type of aggregates also show different type of shrinkage property, and similar behavior is being shown in the your creep value. So sandstone have maximum creep and your quartz will have minimum creep. Other factor which is affecting your creep problem is your extent of loading. So the more you load the sample, the more is the creep value you can see. So this is like at 3 months and 28 days, different type of loading and different type of loading condition. From 2 MPa to 8 MPa we are loading. So more the loading condition, more will be your creep issues. And if we talk about same way other ambient condition, so in this case we are talking about temperature. So if your temperature is more, that means your loss of water will be higher. That cause also your creep and shrinkage value will increase as compared to your lower temperature. And temperature and then relative humidity. So in relative humidity, if you see, your creep coefficient is higher at 50% RH and very low as at 90% RH. Other factor which is affecting is specimen size. So in this case, if you see, this is your height of specimen. If my specimen height is 50 mm or it is thinner only, in that case your shrinkage coefficient is very high, or that curve is very high, slope will be very high. And if your specimen is thick enough, in that case your shrinkage coefficient is low. Okay. So with increase in size, your shrinkage or your creep value is actually decreases. So if you talk about like your mass concreting in dams and all, so what is happening in that cases, your strain value at the outer surface, if your mass concreting is there, so what will happen, your this outer area will have a very different atmosphere as compared to your this inner area. So your coefficient at this point and your coefficient at this point will be very much different. Okay. Then again it is like a different load rates, how your if I am loading it at infinite time, if I am loading it 7 days, 100 minutes, 20 minutes, so initial time your stress level will be higher, or your what's the creep will be much more higher as compared to if you are loading it at a very later age. Why? Because at later age you have chances of complete hydration and it will solidify easily. At T is equal to 20 minutes, you won't even your concrete even harden properly. So in that case you will have a very high creep value. Okay. Then we are talking about what are the negative and positive effects of creep. So negative effect, as we are seeing in previous slides also, if there is creep, your failure strain will reach much more earlier time than as designed by you. So your design strain value will be much higher than your actual strain value, and it may cause cracking in mass concrete structure, where we are telling outside and inside your creep coefficient is different. So what will happen, your outside will crack easily. And other thing is, it can lead to excessive deflection. And again, as we have seen in pre-stress concrete system, what will happen because of creep, there is a loss of stress value in your pre-stressing rebars. So other thing is how positively creep can affect. First thing is, in columns, a gradual transfer of loading between concrete and steel can take place because of creep. However, in eccentrically loaded columns, creep would not have a good effect. Other thing is, creep in combination with relaxation, it can lead to reduce in stress concentration induced by shrinkage, temperature change, or support movement. So if I am loading it initially and then relaxing it, what will happen, your initial loading condition will make it more compact structure, so it will lead to reduce in stress concentration. If you are relaxing it also, if you are putting the loading continuously, it's not a positive effect. If creep in combination in relaxation, then only it will have a positive effect. And this is one of the equipment which is being used at IIT Madras to test the creep value. So this sir might have explained you fully, and what are the what is the working function, working principle of this equipment, and how you are measuring strain values. So we will attach a strain gauge. So here, if you can see, you will attach a strain gauge with it and measure the strain value continuously, and it will be loaded in a constant load value. And then there were some results and all, how it is behaving, and what are the different values of creep coefficient. Those things you can read from the PPT itself. Other thing you might have studied is next topic is about shrinkage. So shrinkage is reduction of volume of concrete due to movement of water. So there are 5 type of shrinkage: plastic, thermal, autogenous, drying, and carbonation induced shrinkage. So what is happening when you are placing your concrete, At that point, if you are not curing it properly, there will be sudden loss of water due to evaporation, and that will cause cracks in your surface of concrete system. That is called as plastic shrinkage. So in plastic, if how you can reduce plastic shrinkage, first and foremost important thing is doing proper curing. Other thing is you can use fibers. So what fibers will do, that will keep your concrete intact enough, it will hold your concrete properly and will reduce the crack width. So if you see here, this is without fibers, and this one is with fibers. So you will say that this with fibers will have more cracks, but if you measure your crack volume, or let's say crack width here, this will have very less crack width and very less crack volume as compared to your crack not volume, it will be mostly area. Your crack area in this case will be much lower than this one. So fibers will reduce your crack width. Another type of shrinkage which is not due to loss of water is carbonation shrinkage. It is mainly change in volume due to carbonation reaction. If anybody remember carbonation reaction? So in carbonation reaction, what is happening here? Somebody was saying something. So your calcium hydroxide present in your concrete will react with CO2 and form calcium carbonate. So what will happen, your calcium carbonate will be much more compact and will reduce the reduction in volume won't be as much as it won't be like clearly visible, but it is it will cause a change in volume, which is called as carbonation shrinkage. Other type of shrinkage, if it says chemical shrinkage. So a minute. So chemical shrinkage is mainly due to the hydration process what is happening. So if you see here, due to your hydration, due to the hydration product forming, your hydration product volume are much more less than as compared to your before hydration product. So when complete hydration will take place, your volume will start decreasing, it won't be. So if you see here, this is your presence of CS, or presence of raw product C3S, C2S, those things, yes. So if this is your hydration product CSH or calcium hydroxide. So as your hydration products will increase, your volume is decreasing. So more hydration will take place, more volume decrease will be there. So this is one setup for chemical shrinkage. So this will automatically measure the chemical shrinkage using diatometry. So these are different, same way, if you see different type of test tube kind of thing, and we are adding CS droplets to it, and will measure the decrease in volume. Okay. Other type of shrinkage is autogeneous shrinkage. So what exact autogeneous shrinkage is due to removal of water from the capillary and your gel pores. So if you remember your microstructure of, you will have CSH gel, and in between you will have intermolecular pores, capillary pores, and then you will have, so here you will have gel pores, and then you will have capillary pores in between. So in between layers you have gel pores, and outside you will have capillary pores. So because of removal of water from this capillary pores and gel pores, water from this area is called as autogeneous shrinkage. So this is also called as self desiccation. Self desiccation means it will happen itself. You need not put any load in that condition, so it will happen a deterioration in its own. So mainly a problem for low water cement ratio or fine material admixture when you are using. Another type of shrinkage is drying shrinkage. It is when your let's say your concrete is in drying stage, or after your concrete set to it hardens. In that case, when there is a removal of water, that is called as drying shrinkage. Only the cement paste and concrete is susceptible to drying shrinkage, as we same way as we have seen in creep. And various factors which are affecting your shrinkages, again ambient condition, relative humidity, temperature, your specimen size, amount of aggregate, and degree of hydration. So if you see here, this is the basic graph we will draw for drying shrinkage, days exposed, and how much there is a change in length. So if you see here, when you are putting it under shrinkage, it is looking like this. After unloading, or let's say after second shrinkage, it will reduce, your length change will reduce a lot. Same way, if you are putting it under expansion, you are expanding it, and if you are second expansion, it will be almost similar graph. So sorry, this is like when you are wetting and drying your specimen. So when you are drying it, that will happen first shrinkage, then you are adding water, expansion will take place, then again you are drying it, second shrinkage, again you are wetting it, second expansion. Okay, next thing is, what is the combined effect of your creep and shrinkage? So if your creep and shrinkage are taking place together, so this is how your graph will look like. So this is your stress after creep relief, and this is your normal tensile strength of the concrete. When your stress after creep relief intersect with your tensile strength of concrete, at that point there is chances of crack development, and this will show your elastic tensile stress value of general stress versus time graph, and the difference between these 2 points will give you the creep value, change in creep value. So if we talk about combined effect of shrinkage and creep strains are always opposed to the applied stress. So creep will cause strain in the direction of stress. They are always additive with the elastic strain. So in direction of elastic strain only your creep will take place. The Poisson ratio is about the same in creep as in elastic regime, so lateral expansion will increase due to creep. Shrinkage strains are volumetric. So if we talk about creep strains, they are always opposite to the applied stress, and they will be always called as additive to the elastic strains. And your shrinkage strains are mostly volumetric in nature, that is, it is same in all direction. And under uniaxial loading, the elastic creep and shrinkage strain will lead to axial contraction, whereas shrinkage and creep may compensate each other in lateral direction. So okay, here it is showing. So this is your basic creep. If I am putting uniaxial loading, what will happen? Your material, if there is no loading here, your material will relax in this direction. So there is a no moisture movement between concrete and ambient, no drying shrinkage, constant stress over time. It is in the case of basic creep. When you are relaxing in during stress relaxation, what is happening? There will be constant strain over time, and your stress is releasing. Your stress will go from elastic state to relaxation state. Now if I am restraining this point, and then I am working on, if my relative humidity is less than 100, so what will happen? Your strain versus graph will be like this. With time your strain will increase. However, if you talk about stress versus time, there is no stress will be generated in this cases, because it's not restrained from any point. So the member is free to move, however your strain is increasing. Now the member is not free to move. In that case, what will happen? Your strain will remain constant and your stress value will be increasing. So there is a development of tensile stress value. Now in this case, when you are allowing it to relax, stress relaxation, in that case again your strain will be constant and your stress will be reducing to which is called as shrinkage. So in this case shrinkage will take place. The previous example is a particular with that one. Okay. So this is basically how you will study shrinkage and creep in hardened concrete. So this is your strain versus time graph. So as we already discussed, with time your strain will increase almost constantly in case of your autogeneous shrinkage. Why we are telling like that? Because autogeneous shrinkage is like a self-depreciating shrinkage where you are not applying any type of loading or anything is happening. So how you will measure autogeneous shrinkage? Mostly you will keep it covered. You will seal your concrete system and allow only your top and bottom part to be exposed. So you are allowing moisture to leave the concrete only from top and bottom part. You are not allowing it to leave from the surface area. However, if I am keeping my side exposed, in that case what we are doing, if we are exposing our sides, in that case you will get a drying shrinkage plus autogeneous shrinkage. So your graph will be sort of like this. So your total loss of water will be this much, and this will give you drying shrinkage and this will give you autogeneous shrinkage. Next thing is, if I am sealing my wall side and also applying load in two direction, top and bottom direction, in that case what will happen? I am having autogeneous shrinkage plus I am having basic creep happening. So when I am loading it, suddenly your strain will increase and then it will get constant. So this will give me basic creep value. Same way, if I am again exposing the sides and loading it, in that case I will have autogeneous shrinkage, drying shrinkage plus my basic creep. So what is happening? It is basic plus drying creep strains. So both type of strains will take place. So this is how we will study different type of creep and shrinkage in our lab. What exactly we need, based on that we will prepare our specimen. So this is an example of shrinkage testing. You will mix it and this will be your initial length, and then what is happening? Self desiccation will happen. There is a loss of water, that is autogeneous shrinkage. And then when suddenly when you are putting it in water after 24 hours, if you are curing it after 20 hours, when you are curing it, there is a little bit expansion in your system because of addition of water, and sample will get wet. And after 28 days, if you are still keeping it in solution, it will be constant, but if you are drying it, it will reduce again, it will cause shrinkage. So what is exactly, if we talk about, when I am preparing my specimen, within 3 to 4 hours I am getting plastic shrinkage, and then till within 24 hours I am getting autogeneous shrinkage here, and then there is a increase in increase in volume, and then afterward, after 28 days curing, you will have your drying shrinkage, and again your other two type of shrinkage will follow up. Carbonation is a long term process, so it will be like least, and there it will, the volume change also will be almost very low. And other is creep testing. So in creep testing, you are mixing your specimen, then you are keeping it in a mold for 20 hours, and then you are allowing the variation in curing in the mold, and then this is your standard curing time, and then for 7 days you are moist curing it. After that 20 till 28 days you are air curing it, and then after 28 days of curing only you are loading it. This is your standard curing procedure. But when you are measuring your creep, after demolding only, you are sealing your specimen, and then you are, after 28 days, loading process will be same after 28 days, but in this case you are curing it in a sealed condition. So other than this, sir might have taught you some experimental thing in shrinkage, where how you can measure drying shrinkage and how you can measure chemical shrinkage. So what complete procedure and some result from one of his PhD student. So those things you can study from your lecture also. If you have doubt on the on the things I have taught and on exactly on the week 10 you can ask, otherwise we will see some question answer for this class. You can ask your question or put in the chat box also. If there are no questions, then we will see the question and answer for today, this week. Okay, so the first question is, the time dependent deformation strains are permanent and non recoverable. True or false?
True.
True. Okay. So if you remember our graph, it looked like this, right? So this is your elastic recovery period. So when you are unloading it, they can be recoverable. So answer is actually time dependent deformation strains are permanent. Okay, sorry, this is about creep only. So if we talk about basic creep, so it is not completely recoverable, it is almost permanent. Second question is, time dependent deformation of the concrete are primarily caused due to aggregate, attringite, ITZ or water.
D. Water.
Water.
Water. Okay, correct. So mainly it is due to the loss of water. Next question is, creep during sealed condition of concrete is more than creep during drying condition. True or false?
False.
False. Correct. So if you see from this condition, during sealed condition your creep is less than your during drying condition. Next question is, as the temperature increases, the viscosity of asphalt increases, decreases or does not change?
D.
Decreases.
Decreases.
This is correct. So viscosity is resistance to flow. When you are increasing your temperature, your resistance to flow will decrease and your asphalt will become more flowable. The internal rearrangement of the structure causes basic creep or drying creep.
B.
Sorry, B. Okay. Anybody who think A is the correct answer? So actually it's a basic creep. So
A.
yeah, when we have seen the definition of basic creep, it is mainly when your CSH will move from one place to another, or it will fill the very small pores in your concrete system. That is your basic creep. Okay. So mainly because of rearrangement of the structure, it will be basic creep. Particle packing based approach of mixed design results in reduced creep or increased creep.
A.
Reduce creep.
Correct. So if our system is well graded, your creep value will be much lower than your other type of. Next question is 15 kg of water kept in a rectangular box of length 2 meter and width 1 meter evaporated within 5 hours. Choose the true statement from below and justify. Evaporation rate suitable to reduce plastic shrinkage. Evaporation rate is not suitable enough to reduce plastic shrinkage. Any idea? So, if we talk about plastic shrinkage, evaporation rate can or cannot be considered as a parameter to talk about plastic shrinkage. What do you think? Should we rely on evaporation rate as a parameter to reduce plastic shrinkage or no?
Yes, yes. It depends upon evaporation rate.
So actually if we
B.
yeah, so in this case we have to calculate it, it should be evaporation rate should not exceed 1 kg per meter square per hour. So now if we talk about in this case you have 15 kg of
1.5.
yeah, your value is coming more than 1 kg. So if your value is more than 1 kg, this evaporation rate is not suitable enough to reduce plastic shrinkage. Okay, if you want you can calculate it once. So it will be 15 by 3.
1.5, madam.
Yeah, okay. Next question is when concrete is subjected to alternate wetting and drying cycles, the shrinkage increases with each drying cycle. True or false?
False.
False.
False. So you remember that graph we talk about. So this is cycle 1, this is cycle 2. So with each cycle your shrinkage is actually not increasing. In the restrained steel ring test for shrinkage, it is considered that drawing shrinkage strain on the concrete is greater than strain experienced by steel ring. Drying shrinkage strain on the concrete is lesser than strain experienced by steel ring, or drying shrinkage strain on the concrete is equal to strain experienced by steel ring. So this is a test which we are doing for drying shrinkage value. So if you see from here,
C.
C.
I think.
C is your correct answer. Oh no, sorry, not C. We are telling in the restrained area, it is considered that the drying shrinkage strain on the concrete is greater than strain experienced by steel ring. It is lesser than balanced by elastic and in the concrete in combination with elastic contraction steel and steel. Okay, so your drying shrinkage strain on concrete is actually a combination of strain in steel plus creep strain. So in that case your strain in concrete is equal to steel strain plus your creep strain. So that means your A will be correct answer. Your shrinkage on concrete is greater than strain experienced by steel ring. Okay. Okay, imagine two bridges A and B. Let's assume that both the bridges have same specification and load exerted except their location. A is located at Rajasthan and B at Chennai. With given information, which of the bridge is likely to creep more in 20 years?
A.
A.
Correct. So, because of the temperature change at A, we have seen that temperature graph also. More the temperature, more is the creep issue. Which concrete constituent mainly contributes to creep? Aggregate, cement paste, reinforcement or admixture? Main effect will be due to
Cement paste. B.
correct. And secondary is due to addition of a different type of aggregates. Creep strains are always volumetric, opposed to stress, additive with elastic strains, or none of the above.
B.
B. B.
P actually
B.
it's additive with elastic strain. So we were discussing like it will be in the direction of your stress only, and it will be additive with the elastic strains. Let me confirm it. Okay. Okay, it is always opposite. Okay, so B and C both are correct answer. I will correct this thing. So opposite to stress as well as it is additive with the elastic strain. Okay, sorry, I will correct it. Next question is, shrinkage strains are directional, volumetric, temporary or non-measurable?
B.
B.
Oh, correct. So same way, shrinkage strain will be equal in all direction and will be called as volumetric. Which of these reduces shrinkage? More aggregate content, higher water to cement ratio, higher temperature or less curing? Reducing shrinkage.
A.
A.
A, correct.
A.
So if you have lesser paste and more aggregate content, the chances of shrinkage will be much lower than otherwise. In restraint shrinkage, creep helps in stress concentration increases, stress relaxation, crack widening or thermal cracking.
B.
B,
B.
B, correct. So in case of restraint shrinkage, when we are restraining the sides or any side, in that case what will happen, creep due to creep or due to loading, it will help in stress relaxation of your system. Which shrinkage is not due to water loss? Drying shrinkage, autogenous, plastic or carbonation? Sorry,
D.
A,
D. D.
D,
D.
correct.
D.
So drying shrinkage is after during curing period. Autogeneous is when it is hardened, like initial hours to when you are keeping it in the curing period, that time. Plastic is when your cast is just after 4-5 hours. So the one in which there is no water loss is carbonation shrinkage, which is happening due to chemical reactions. Aggregate grading affects shrinkage because it influences modulus of elasticity, reduces hydration, increases surface area, affects the porosity.
A.
A. Anybody
B,
else?
madam. B.
B. So actually, when you are grading your system properly, it will influence your modulus of elasticity. So A is the correct answer. The empirical relation log Cp by Ce is equal to alpha log A minus A, alpha log 1 upon 1 minus G minus U is used to relate creep of paste and creep of mortar, concrete, cement or reinforcement.
B.
B. Concrete.
Correct. Which experimental condition is most severe for plastic shrinkage cracking? Higher relative humidity, low wind speed, low relative humidity, high wind speed, and 35 degrees Celsius, sealed curing or water ponding?
B.
B,
B.
correct. So we have seen that graph of humidity also. If your 50 RH is there, then your shrinkage is much more as compared to your 90 RH. That means in dry condition and high wind speed, your shrinkage will be much more. Pavement cracking due to shrinkage can be minimized by increasing cement content, providing expansion joint, increasing water to cement ratio, or reducing aggregate size.
B. B. B.
B, correct. If you provide expansion joint, your cracking due to shrinkage can be reduced. Fiber reinforced concrete helps reduce plastic shrinkage crack because fiber reduce water demand, provide crack bridging and delay crack opening, increases slump value, eliminate hydration heat.
B.
B.
B, correct.
B.
So we have seen those graphs where your complete crack area is reducing due to addition of fibers, so it will provide crack bridging. To minimize plastic shrinkage cracking in bridges decks exposed to hot dry winds, one should delay curing for 3 days, increase cement fineness, rapid curing, fogging and windbreaks, or use high slump concrete. So to minimize plastic shrinkage, what we should do?
C.
Correct.
C.
So that's all for this week. If you guys have any doubt, you can ask now, or any doubt in this week, any question or any concept you guys have any doubt?
Madam, explain about thermal shrinkage. Thermal shrinkage.
Just 1 minute, I will reply. Actually, I am having some issue with my YouTube channel, so I was not able to upload all the videos. I will add the videos and PPTs by today. Okay. Videos I am not sure if I will be able to add. PPTs I will add for sure. Okay. Thermal shrinkage. So whenever there is a increase in temperature, what will happen? There is more loss of water, right? Increase in temperature in atmosphere, what will happen? Evaporation will happen of water, that is causing the thermal shrinkage.
In which time, madam? Period of time.
That will be mostly during like we are telling autogeneous and drying shrinkage period of that only, within 28 days. Like should not be before complete hydration.
Okay, madam. Means after plastic shrinkage, it will be happen.
Thermal shrinkage is part of autogeneous and drying shrinkage stuff.
Okay, madam. Thank you, madam.
Any other doubt? If you guys have no doubts, you can leave the meeting also. We'll close the meeting in 5-10 minutes.
It's fiber. In the fiber play in role after first crack or before initial, because in some experiment the first crack when we use fiber, the first crack appeared after 8 to 10 days. And in lecture in one testing about impact of concrete after fiber used, the impact number is going increase due to fiber.
1 minute. We'll check the slides. So, which slide you are talking about?
Actually,
Like one test is done, that one you are telling, where sir is explaining one experiment.
yes, yes, ma'am.
Okay.
In which when we use steel fiber, the number
Hmm.
of blow is going increase. Mainly, I want to know the fiber when fiber start play their role
It
after
will
first break or
no
before.
initial itself. Like if we talk about shrinkage only, your plastic shrinkage it will reduce because of addition of fibers. So it will hold your concrete in a close, like it will keep your concrete in a compact way. It will avoid crack to expand. So from initial stage itself, your plastic crack will be much more lower when you are adding fibers as compared to without fibers. So mainly in plastic stage also your fibers will be helpful.
Okay, okay. Thank you.
Okay, if there are no more doubts, I will close the class for today. Okay. Thank you everyone for joining the class. Meet next week.